Hello, this video is for the IXL activity titled Interpret the Graph of a Function. They are indeed word problems, and the three-character code for this activity is Sierra Tango Uniform. At the time of this recording, this activity can be found in A1.Q.16. All right, so we have a graph here, and we got a question to go along with it. I'm assuming we're going to use some information from the graph to answer this question. And what we know about graphs are the important thing to remember is that the graph line of the function represents all the possible solutions of that function. So whatever this function is, it gets graphed here and is a visual representation of all of the possible solutions. So let's go ahead and read the question up here at the top. The graph shows how Ava's bank account balance is related to the number of movie tickets that she purchases. Well, all graphs should have a title, and indeed we have bank account balance, so we have our title. Our x-axis and y-axis, that is to say the independent variable and the dependent variable, or the inputs and the outputs, that they should have titles on them as well. We see that the independent variable, values of x, is the number of movie tickets that she purchases, whereas the dependent variable, or the y values, is indeed the balance, and we see that in dollars there. And she starts with $60 whenever she's bought no tickets, and as the number of tickets that she purchases increases, the value of her bank account, or the balance in her bank account, goes down. Well, that makes sense. The more tickets you buy, the less money that you have. Let's look at some examples here. If in the event that after she buys 2 tickets, we'll go up there and look and find the line of the graph, or the line of the function, sorry, and then we go over and see what value would that have at that point. And it looks like it may be about, what, maybe $44? Or maybe what about after she buys 5 tickets? After she buys 5 tickets, we would look over and see that the corresponding value is $20. So in this case, we can tell that apparently we'll be given either an independent variable, a value of x, and then we'll have to find the corresponding dependent variable, or the corresponding value of y. Some of the questions will go the other way around. They're going to give you the dependent variable, the y value, and you might have to find the corresponding independent variable, that is to say, the x value. So let's go ahead and I'm going to erase my examples off of here, and let's look at this first question. It says, if Ava buys 5 movie tickets, oh, amazing. That's one of the ones I chose a second ago. If she buys 5 movie tickets, what will the account balance be? So they're giving us the number of tickets. It's important to know which one are they giving you. So this means that they are giving us an X value. So our answers down here must be Y values. And that makes sense because they're in dollars, right? And we see dollars going up and down the Y axis there. So I'll find $5 once again. We locate the value of 5 on the x-axis, go up to the line of the function, and then find out what its matching y value is. And indeed, we see that it is $20. Looking at the next question, let's go ahead and read the question. The graph shows how the number of salad plates that Sean has left is related to the number of tables that he has set. So our title, number of salad plates remaining. Our x-axis is the number of tables. Our y-axis is the number of salad plates remaining. So as he sets the tables, as the number of tables that are set increases, the number of salad plates remaining decreases. That makes sense. He's back in the kitchen, got a bunch of salad plates. He's out putting them on the tables. Well, as he takes them out of the kitchen and puts them on the table, we have fewer salads remaining back in the kitchen, right? So how many tables does Sean need to set in order to have just 500 salad plates left to distribute? So let's determine what are they giving us. They're giving us a y value, so that must mean that all of these are x values, and indeed the number of tables is down on the x-axis. So let's go ahead and match up that 500, find the 500 plates remaining. Take this over to the line of the function here, all the way down to the end. And then we match it up, and it looks like there would be 100 remaining. So 100 tables would remain. This graph shows how the total distance, Tisha, or is it Tisha? I'll go with Tisha. Has walked depends on the number of trips she's made to school. So total kilometers Tisha has walked, x-axis, number of trips, y-axis, total distance she walked. So as the number of trips increases, her distance increases. That makes perfectly good sense to me. So let's go ahead and determine y-axis or x-axis. How many trips? So they're asking us how many trips. This is the question, right? They say how many trips. So x is what we're looking for. So they should be giving us a y value. Well, she have to make in all to walk a total of 400 kilometers. So that, nope, not x. That should be a y. Where's that undo arrow? There. Only need half of it. There we go. So they're giving us a y value, and we're going to look for an x value. So looking along the y-axis here, our dependent variable, we locate 400, run it over here, and find the matching x value. And we see that it is indeed 40 trips. All right, on our next example, the graph shows how the number of yards of fabric that Claire has left is related to the number of dresses that she's sewn. So I like the way they say is related to. So it is a relation, and it is indeed a function as well. Remember those conversations we had about the differences between relations and functions. So let's see. Yards of fabric remaining. Here we have dresses that are sewn as our x-axis, yards of fabric remaining. So as the number of dresses sewn increases, the yards of fabric decreases. Again, makes sense because we are, or Claire, not me or you, is making dresses with them. And so as they make dresses, they use up fabric and they have fewer and fewer um, yards of fabric remaining. So if Claire sews 3 dresses, they must be giving us an input or a independent variable or the x value, right? So they're giving us the x value here. If she sews 3, how many yards of fabric, which is the y value, will she have? So they're giving us the x value, and we need to find the y value. So let's find 3 dresses down here and match it up with the line of the function, and then go over and look at the value of y at that point. And it looks like it is indeed, oh, don't want to move that. Put it back, put it back. There we go. We'll leave it at that. 2 yards of fabric remaining. This graph shows how the number of pages Jackson still has to write for a research paper depends on the number of hours he spends writing. So the way that they say depends on lets us know which one is the independent variable and which one's the input. It says that the number of pages, let's see, number of pages depends on the number of hours. So we know that the number of hours, just from the way it's worded, is the x value, the independent variable, and this is the y value. Remember that the x values are independent variable because we can hang the I on the x-axis there, and then D is the dependent variable. By the way, we can hang a D on the y-axis. So how many hours of writing will Jackson have to do in order to have 1 page left to write? So let's go ahead and find our value. 1 page left. Well, this is hours spent writing. Notice that this one might be a little more difficult because both the x values and the y values are all increments of 1. 1 through 10 on the x-axis, 1 through 10 on the y-axis. So this is where understanding the independent variable from the dependent variable and also the labels that are on the x and on the y-axis come in pretty handy. So we're looking for pages left, number of pages left. So that's right here. And we'll go over and match that up with the line of the function. And then we see that we would have, or Jackson would have, 4 hours. How many hours of writing will he have to do? He's going to do 4 hours to get down to the point that he only has 1 page left. Let's see. He had to start with 7 pages, right? It's a nice research paper. I don't think I'd want to write it. Then you'll get some questions where you have to fill in the blank. We have here the blank. It's no longer multiple choice, but hey, I think we can handle it. This graph shows how the total cost of visiting the Science Museum as a member is related to the number of visits. Here we have members' cost to visit the Science Museum for a title, Every graph should have a title. Our x-axis is the number of visits. It's going to determine our cost, which is our y-axis. We have that here in dollars. So it says, what is the maximum number of visits a member of the Science Museum can make for a total cost of $90? So they're telling us the y value, the dependent variable. Let's go ahead and find 90 on the scale here. There it is. Let's follow it over and match it up with the line of the function. Now let's go down and see what our corresponding x value is, and or number of visits in this case. And we see that it is 9. I was going to say 9 as well, but that's actually 90, and that's 9. So I believe I have one more question here, where this graph shows how the number of bread plates that Vicky has left is related to the number of tables that she sets. So we got one, I think we got a waiter putting out salad, and now we got Vicky, assuming she's a waitress, is putting out, what is it, bread plates, right? So how many tables does Vicky need to set in order to have just 300 bread plates left to distribute? So 300 bread plates, we see bread plates is our dependent variable. So let's go ahead and locate that. 300 is the number we're looking for. Go over and match that up with the line of the function. And we see that indeed it is 50 tables remaining. All right. So those are all of my examples for the IXL activity interpret the graph of a function, word problems. Now go level up your learning.